Thank you for joining us for today's webinar. My name is Neil Foley and I'm the Applications Engineer here at RIZE. Today I'm going to be talking about some of the applications of our new RIZIUM carbon material for 3D printing. So first off, I'll just go over some of the general things you should know about RIZIUM carbon, especially related to the materials that we already have released. So RIZIUM carbon is based on a very similar polymer that was used in our initial material, RIZIUM 1. So it retains many of the same benefits of RIZIUM 1. These include its very strong chemical resistance, moisture resistance, and its ability to print without any production of volatile organic compounds in the air. In addition to those effects, it also is infused with short strands of chopped carbon fiber, which lends a variety of different benefits, including improved stiffness, toughness, and a higher quality surface appearance. So some of the primary benefits of having those extra characteristics is, for one thing, the ability to produce even larger parts. So one of the issues that's always present with thermoplastic filament extrusion printing is that there's always a limitation on how large a part can be produced, because once a part reaches a certain size or a certain level of bulkiness, it will begin to follow negative effects from thermal contraction. So the effect of infusing RIZIUM carbon material with chopped carbon fibers is that it reduces this effect of thermal contraction so that you can produce even larger parts than you could have with RIZIUM 1. So it allows for a lot of bulk and a lot of extra strength just because of that. Another useful thing you can do with these new capabilities is produce more rigid components, particularly for demanding industrial applications. So this would include things like tooling, jigs, fixtures, and replacement components. And generally, RIZIUM carbon is able to achieve a stiffness of up to twice the stiffness of RIZIUM 1 if oriented optimally. And finally, RIZIUM carbon is valuable for producing visually impressive models and prototypes because of the higher quality surface finish that it can achieve. There we go. So now I'm going to go over some of the basic features that are offered by RIZE 3D printers and how those will then relate to using RIZIUM carbon. So RIZE has a patented process called augmented polymer deposition, wherein we combine thermoplastic filament extrusion with the jetting of different functional inks from the type of printheads you would find in a 2D printer. So typically the way this process would work is initially a support bed is extruded at the bottom using the thermoplastic filament, and then in our case we jet a release ink on top of that from the 2D printheads, and then we continue to extrude layers of thermoplastic on top of that, applying different additional functional inks to the interior of the part. Now in the case of RIZIUM carbon, it's a very dark material, so using marking inks will not have much of an effect, but it can still benefit a lot from using release ink, which can drastically increase the rate at which parts can be post-processed. So here is a general look at the material properties of what is called a cycloolefin polymer, and this is the base material for RIZIUM 1 and RIZIUM carbon. And some of the primary benefits of using this are, as we've mentioned, zero emissions, no volatile organic compounds or any gaseous materials are emitted from the part as it prints. Also, there is negligible moisture absorption. It's very moisture resistant, and because of that, parts printed with RIZIUM 1 or RIZIUM carbon are going to be very effective for outdoor use compared to similar technologies. And it's also a very clean material. It's clean in the sense that, as we've mentioned, it doesn't emit any harmful chemicals, but it can also be recycled using the simple typical processes, and it doesn't require any special material handling either for the thermoplastics or the inks that are applied to them. So using these technologies, these material properties coupled with RIZE's augmented polymer deposition, we're able to achieve a large variety of different applications. So using carbon composites, we can produce very rigid, strong parts that are useful for manufacturing, among other things. Using marking inks that embed color into the surface of parts as they print, we're able to achieve a variety of different effects, including prototyping consumer products, modeling life sciences and geographic regions, as well as visualizing simulations. As you can see in the bottom right, there's a visualization of a simulation model. And some of the other benefits include, because of the release ink that allows you to very rapidly and easily remove support from parts, you're able to rapidly post-process even very complex shapes like the generative shape shown in the bottom right here. And that allows you to really take advantage of the benefits of generative design. And then there are also some other applications in fields such as education, where safety is very important, and in that case, having zero VOCs emitted is a very valuable component. So more specifically to RIZIUM carbon, here are some of the different things that it's already being used for. It's being used for work holdings, robot gripper fingers, a variety of different custom fixtures, and service parts, which can come into play anytime that something breaks in a factory and a solution needs to be found. And in many cases, printing the replacement part on an existing 3D printer can rapidly improve the cost and lead time of getting the machine back up and running. There's also a few other examples here, gauging parts and end-use parts. So this goes into a little more detail on some of the topics I've already mentioned, as well as bringing up a few more. So because RIZIUM carbon is able to achieve such a high strength and stiffness, it's ideal for applications in industrial environments. As I've mentioned, both RIZIUM carbon and RIZIUM 1 are based on a cycloolefin polymer matrix, and using this material has a variety of benefits in terms of safety, chemical resistance, and thermomechanical properties. Because RIZE 1 is a platform that not only supports RIZIUM 1 and the initial inks that we shipped the system with, it also has the ability to expand with new capabilities such as those offered by RIZIUM carbon. And by releasing RIZIUM carbon to this existing machine, customers who already have a RIZE printer can expand their capabilities without needing a new printer. Also, RIZIUM carbon, as I've mentioned, is able to produce much larger parts because it is so resistant to warpage from thermal contraction due to the rigidity supplied by the chopped carbon fibers, and it's also able to achieve a very nice surface finish. So now I'll go over some of the best practices you should consider when working with RIZIUM carbon. So some of the things you might care about include support removal, where it's best to try to prepare the part in such a way that support removal will be easy, and you'll also benefit from the existing processes that have been designed for use with RIZIUM carbon. So because RIZIUM carbon is a stiffer material, the supports will also be stiffer than those printed with RIZIUM 1, and so the process can be a little bit different to remove them. Typically, the best approach is to peel around the edges first and then peel the entire thing off once you've released from the edges. Another thing to consider is if you're trying to produce parts with high stiffness, one of the best ways to accomplish that is by making sure that the part is oriented ideally. So the best rule of thumb is to try to orient strength critical features horizontally. So if you have a part that is long and narrow, then you'll want it, rather than standing upright, to be laid down in a horizontal position so that the walls of that part can fully benefit from the rigidity of the carbon fiber reinforced tool paths. And finally, if you are focused on improving surface finish of parts, you'll still want to use the typical approaches to improving surface quality, such as eliminating shallow slopes by reorienting the part, and if you're unable to fully eliminate shallow slopes, making sure that their angles are equalized so that it's not one of them is very close to horizontal and thus illustrating more stepping than the other one. And then here's a last topic about some of the things you'll want to consider when designing for additive versus traditional manufacturing. And because RIZIUM carbon is such a useful material to use in manufacturing environments, it's likely that a lot of its applications will be replacing or supplementing applications that are currently done using metal machining technologies. And so one of the things that should be considered when deciding whether or not to complete an application using RIZIUM carbon or a metal process includes, one of these is production time. So one of the things that's different about 3D printing versus traditional manufacturing is that typically with traditional manufacturing, you're starting with a lot of material, and the more material you remove, the longer it will take to produce the part. And with 3D printing, the opposite is true. Adding material to an empty build plate is how you create the parts. So in 3D printing, it's typically best to minimize the size of parts in order to maximize the speed. Whereas with traditional manufacturing, it's not just about size, but also complexity. But generally speaking, the less material you have to remove, the faster the production can be completed. Now, I've mentioned complexity a few times here. One of the great benefits of 3D printing is the ability to create very complex surfaces without any additional cost or time, and that is not true for most traditional methods of manufacturing. And because of that, if you do have some sort of application where you need a very smooth, complex surface, for example, to hold a mated surface on some sort of piece of work that needs to be held, then using a 3D printing technology with a sturdy material like RIZIUM carbon will be an effective and low-cost way of getting that done. So some of the appropriate applications for using RIZIUM carbon in a manufacturing environment and replacing a traditional method, some of the things you'll need to consider when making that decision include whether or not you have a full understanding of the stresses. So a lot of work that's done with metal that's been produced by traditional manufacturing methods does not necessarily need to be made in metal and could be just as effectively produced with a less strong but still sturdy material like RIZIUM carbon. So the trick to determining whether or not that's an appropriate application for you would really be deciding whether or not you really know what the stresses are going to be that are affecting that part. If you have a very good understanding, then you can just run the numbers and you'll know exactly whether or not RIZIUM carbon will be an effective substitute. In other cases, you might have some sort of application using metal and you may not have done the analysis and you may not know how much the part is really being stressed. And in those cases, you'll have to be more careful about replacing that part with a 3D printed substitute. So ultimately, the real benefit of using RIZIUM carbon is that you don't need to devote as much time and materials to metal production, because you'll often find that using RIZIUM carbon or a 3D printing method in general can take care of some of the work that is extraneously increasing demand on metal production, and that allows you to focus your metal production machines on the pieces that really need them. So that's all I have for today's webinar. Thank you all again for attending.